before I begin with the new stuff, let's just quickly review what we already know about DT graphs. Brennan, I need you to turn around, okay? The important guy's over here now. With all due respect to Josh, he's not that important right now. Okay, so quick review here. A displacement time graph or position time graph shows the object's what? Position. That's why it's called a position time graph, right? And so when you're trying to find displacement, you read it right off the graph, right? Like if I want to know where it went, like if I've got a straight line like this, and let's say this is time is 2 seconds and time is 5 seconds, and I want to know the displacement, well, I just read the 2 points off the graph and do what? Subtract, right? Displacement. And if I want to know velocity, what am I interested in? The slope. The slope of the DT graph is the velocity. I should have practiced my handwriting over spring break. The slope of the DT graph is the velocity. Okay. You have to put all that aside because now we're going to be talking about velocity time graphs. Okay? Velocity time graphs are a whole other kind of graph. They look the same, graph, but a little bit different. Okay? So we've got to be aware that we're changing things up. So after this, you're going to be able to find the following 5 things. Average acceleration, displacement, average velocity, instantaneous velocity, and instantaneous acceleration. 5 things. Let's begin with acceleration. This, I believe, is exactly what you guys have, right? So, average acceleration. Oh, I'm sorry. I said clicker and I forgot it was perfect. We won't forget about it. Average acceleration is calculated the same way that average velocity is calculated on a position time graph. That is by using the slope formula. So, acceleration is the slope of the VT graph. Acceleration is the slope of the VT graph. A few people are catching the clue and writing that down. Some others haven't figured that out yet. Acceleration is the slope of the VT graph. Just like velocity is the slope of the DT graph. When you take intro calculus, advanced math with Mr. Ray, maybe in grade 12, you will find out that that's called the derivative. Okay? And some of that stuff will make sense. You go, oh yeah, okay, that was what Mr. Bennett was talking about in physics class, if you remember. Okay, so how do we find, again, we're talking about velocity time graphs today. So how do we find the average acceleration for interval A? Well, interval A, I've highlighted it here. It's from 0 to 2 seconds. Is the slope between 0 and 2 seconds positive, 0, or negative? Looking at the picture. Is it positive, 0, or negative? It's positive, right? Everyone can see that, right? The slope of this line here is positive. How do we find slope? Rise over run. How much does it go up? It goes from 0 up to 4, and it runs from 0 to 2. So the rise is 4, and the run is 2. 4 divided by 2 is 2 meters per second squared. Units are important. Acceleration units, meters per second squared. Okay? So I'm asking you to find average acceleration for interval A. I just did it for you. You can't get it wrong. Well, you can, but you know. I have to click start, which I will do. Okay, so what is the slope for interval A? The slope of interval A is 2 meters per second squared, which is the acceleration. The acceleration. Okay, so go ahead and enter the number 2 for A, for number 1. You should all get it right.
Number 2.
Well, that you're going to have to do on your own. See, I showed you how to do it. Now you're going to do it. Right? Again, we are finding the slopes. So, go ahead and tell me, what is the average acceleration for interval B, C, D, E, and F? Is there one more? Yes, there's also one more. There's a question number 7. Oh, there's question 8, 9, 10 too. Oh, there's a whole kind. Okay, well, you guys go up to number 6, and I'll wait for everyone, and then we'll move on from there. So find me average acceleration for intervals A to F. Go. Okay, I'm going to move on here. So question number 7 is, when is this object stopped? What intervals? And there could be more than one answer possible. When is this object stopped? And your possibles are interval A, B, C, D, E, F, G is never. Again, interval A, B, C, D, E, and F, right? So D is that little bit down there. E. You guys, I think you should have the list of the times, don't you? Yeah, you do. You'll also notice in the picture that they're across the top. So the question is, when is the object stopped? And you can answer more than one if you choose. I'm not saying you have to, I'm saying it's possible. Okay? When is it stopped? And again, all right if you make some mistakes here. We're learning. Bailey? Okay, along a similar line, when is it moving backward? Intervals A, B, C, D, E, F, or G is never. More than one answer is possible. Definitely a thinker. Talk to your neighbor if you need to. When is the object moving backwards? You don't have to enter more than one. It's just possible. When is the object slowing down? Intervals A, B, C, D, E, F, G is never. When is the object slowing down? No. It's A, B, C, D, E, and F. Andrew, Josh, and Braden. Did you press enter? Renee, don't, better to make your own mistake than make someone else's. When is it speeding up? Intervals A, B, C, D, E, F, G is never. More than one answer is possible again. When is this object speeding up? A, B, C, D, E, and F. Not easy questions. The average person on the street would score 0%. Josh and Morgan. Last one, I think. When is the object moving at a constant speed? And again, more than one answer is possible, but not necessary. A, B, C, D, E, F, or interval G. Answer G is never. When is it moving at a constant speed? I will warn you, these marks on this particular little clicker quiz tend to be quite low. Do I have one more? No, I don't. Okay, so I will wait for these 4 people, 2 people, 1 people, and then I will press stop, and then we'll see. And then we'll do some learning. Yay, the first one everyone got right. That's why I do that, so that you can't get 0.
Hey, so like, we supposed to put all the answers in, like, for like answer more than one possible?
No.
Oh, I got them all wrong. Yeah, so did I.
What do you mean?
Okay.
Well, let me go through the answers. Let's go through the answers. Okay, if you got a low mark, here's what you need to do. Listen for the explanation. Okay? Listen for the explanation. Everyone got A right because I told you the answer. The slope was 2. I'm hoping everyone got the second one right too. Oh. The slope is 0. The slope, it's flat. You don't even have to calculate. It's 0. Maybe one thing you might learn today is don't listen to other people. Figure it out for yourself. Number 3, what's the slope? You should have got -2. Right? And I see the vast majority of you got that. -2. Would you say that the slope for the next one is also the same, -2? Sure looks like it. How'd we do? Not quite as good. It's the same line. The next one you should all get. What's the slope? 0. The slope is 0. Right? It's flat. What's the next slope? +1. That's pretty good. Okay, that's up to number 6. Okay, now the harder ones. Let's start here. Listen carefully, you guys. Here's where I'm going to explain it. Listen. It's number 7. When is it stopped? The answer is G. Never. This is not a position time graph. On a position time graph, when it's flat, it's stopped. But this is not a position time graph. This is a graph of velocity. And when the velocity is 0, I didn't trick you. I told you everything you need to know. I did sort of trick you. But I did it on purpose because this is the most common mistake there is. And so I gave it to you in a question format so you would remember. It's when the velocity is 0. Is the velocity ever 0? Right there for an instant. And right there for an instant, and I guess you could argue right there for an instant. But over an interval, it is not 0, ever. The answer is G, never. Did anyone get it right? Yo, there was a couple people. Well done. Well done. Okay? Does that make sense to you? Nod. Yes. Does it make sense? Megan, am I speaking English? Yeah? When the velocity is 0, it has to be at 0 for over an interval for it to be stopped. Now, when is it moving backwards? Again, this is a graph, Andrew, of velocities. Moving backwards means that the velocity is negative. When the velocity is negative, it's moving backwards. When is it negative? There, there, and there. That's A, B, C. That's D, E, and F, isn't it? D, E, and F. Does that make sense? When it's negative, Josh? Yeah? Awesome. I'm making sense? Yeah? Okay? Don't worry, you're going to get a chance to correct, like to get another chance to prove you know how to do this. It's okay. Okay?
Clickers don't go towards the grade, right?
Clickers do not go towards your grade. It's just, all it is for me so I know what I have to reteach. That's all it is. Stop worrying about the grade, you guys, and start worrying about learning something. Okay, so you know what? Okay, would you like to be able to change your answer for number 9? Somebody might have got it right. When is the object... Oh, that's number 8. I got to go to the next one. When is number 9? When is it slowing down? Well, I like to say when the velocity approaches 0. When the velocity is getting closer and closer to 0, that means that it's slowing down. So when is this approaching 0? When is it approaching 0? Right there. It's going towards 0. And right where? There.
I put F and I got it wrong.
The correct answer should be D and F.
I got it wrong.
That's C. I meant C. C and F, yes.
I put F, I got it wrong.
Did you put C and F?
You told me I only put one.
I didn't. I said more than one is possible. It's not necessary. I'm not saying you have to put 2. You can put 2. Because you didn't put both.
I was like, you want me to put both? So I don't only put one.
I didn't. You didn't ask me that question. That may have been the question you thought you were asking, but that's not what I heard. So the correct answer is C and F. Fair enough, Alice. Again, it doesn't matter about the marks. Stop worrying about your mark, you guys. Seriously. Worry about learning something. Way more important. C and F. When is it speeding up? When the velocity does what? Yeah, or moves away from 0. Moves away from 0. When is it doing that? A and D, right? A and D. It's moving away from 0. A and D. Yes? Makes sense, Alex? Yeah? Good? Just want to make sure that I've explained it thoroughly. That's what's important. Okay, what about number 11? When is it moving at a constant speed? B and E. Right there. Flat and flat. The flat indicates that the V remains the same, right? Velocity stays the same. That would be E, right? B and E, yes. Intervals B and E. Yeah, that would. And that's important, Josh, right? Yeah. B and E. Okay. Let's talk about displacement now. Okay. So remember, velocity time graphs not the same as position time graphs. Different. Displacement. Pay attention. Here's the learning part. Guess what? There's going to be a little clicker quiz coming up. Displacement on a VT graph is determined by calculating the area between the graph and the time coordinate over the time interval in question. If you're one of those highlighter people, and I saw a few out there, this is what you want to highlight. You are finding the mathematicians call it the area under the curve. Physicists can't say that because in math the curve is always above, almost always. In physics it's sometimes below. So it's the area between the graph and the time coordinate, or the x-axis. See how I've got that shaded in? That's the area. In the example, here's your example. The displacement for the time interval A would be equal to the area of the triangle formed by the graph and the time coordinate. So interval A is from 0, to 2. And so we go the area from the graph all the way down to the axis. So the interval, or the area of that gray triangle. Does that make sense? And you all remember the formula for area of a triangle, right? It is half the base times the height. Some of you may have learned it as base times height divided by 2. They're the same thing. Right? So half the base. The base is from 0 to 2, which is a base of 2. The height is from 0 to 4, which is a height of 4. So 1/2, the base is 2 times 4. 1/2 times 2 times 4 is 4. Right? Half of 2 is 1 times 4 is 4 meters. Meters, displacement. Meters. I'll talk more about units in a bit. If more than one time interval is to be used in the calculation of displacement, then the total displacement is the sum of the displacements. In other words, you have to add up the triangles. If the displacement for the intervals A and B were to be calculated, the following technique would be used. So interval A is already shown to be 1/2 times 2 times 4 is already 4. How do I find the area of interval B? Well, there's B. I go down to the x-axis and I shade it in. It's not a triangle, Mr. Bennett. It's a rectangle. Area of a rectangle? Base times height or length times width. So from 2 to 5 is 3. From 2 to 5 is 3, and the height is 4. 3 times 4 is 12. The total displacement is 16. This is the 4 from before, right? This is the gray triangle, the 4. This is the 3 times 4. The 12 is the red rectangle. And because I've asked for intervals A and B together, I add them together. Okay? So I get 16. Now pay lots of attention here, because people get this wrong all the time. If the graph is below the time coordinate, if the graph is below the axis, then the displacement is negative. The displacement for the time interval D would be calculated as shown below. Now, I want everyone to shade this in. Interval D is this guy right here, right? Okay. This is what everyone does. Don't do this. This is wrong. Do not do this. People find this area. Wrong, 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 wrong. How come? It's the area between the graph and the axis. So it's actually up. It's this area. It's between the graph and the axis, not below the graph. Right? It's between the graph and the axis. So it's there, and it's negative. So I go from 7, we'll say, to 8.5 is a base of. From 7 to 8.5 is a distance of 1.5. And from 0 down to, it looks like -3 is -3. So I have 1/2 the base, 1/2 of 1.5 times the height -3. I get -2.25 meters displacement. A week away, and my voice is already starting. -2.25 meters. Big, big star beside that. Okay? Don't mess that up. All right. Guess what's coming? You're going to find displacements for the remaining intervals. I did 3 of them. You're now going to find the displacement for intervals C, E, and F. And then we will stop. Here's the learning part. Okay, so interval C, the correct answer should be 4. It looks like most people got that. It's going to be, right, from 5 to 7, the base is 2. The height is 4, so it's going to be 1/2 of 2 times 4. 4 meters. Get your units right. Okay? Interval E, it's a rectangle. Josh, it's a rectangle and it's below. Right? It's from 8.5 to 11 is a total of 2.5. From 0 to -3. 2.5 times -3 is -7.5. Don't forget the negative. Right? It's below. Don't pack up, you guys. Just relax. You'll have time. Okay? This one here is also negative. Right? It's a triangle, so it's from 11 to 14. It's 1/2 because it's a triangle. 11 to 14 is a distance of 3. The height is from 0 to -3. 3 times -3 is -9. Half of that, -4.5 meters. minus 4.5 meters. Okay? Everyone good? Alright, clickers away. I'll see you tomorrow. That doesn't mean leave, it just means I'm done talking.